Welcome back to the VMware Community's Roundtable, wrong podcast, vBrownBag Tech Talks today. I'm Tony Foster. I work for Dell EMC. Quick set of disclaimers before we get started here. The first 4 bullet points are important, the last 2 not so much. So, what are we talking about? We're talking today about doing virtual GPUs inside of Linux VDI desktops. So that means taking a GPU, graphics power, and putting it inside of a virtual desktop that's running Linux and having some crazy awesome capabilities. Now, it's important to note that the stuff I'm going to be discussing today is not supported. And that's going to be stressed a lot throughout this, and you'll see why. So, doing a little bit of throwback to 2012. In 2012, at the vBrownBag Tech Talks, there was a whole not supported series that was done. And this is the actual poster from the vBrownBag Tech Talks in 2012. First rule, don't talk about not supported. Second rule is rules are meant to be broken. So we're going to talk about stuff that is not supported. That said, here's our quick overview agenda. We're going to do a quick overview of all of this. We're going to hop into the host configuration. That way you know all of the wonderful secrets about configuring the new NVIDIA GRID Pascal cards for VDI. So there's a new release and we'll talk about that a little bit. We're going to talk about some of the licensing, some of the virtual machine configuration, and then you're going to actually get to see what test results I came back with when I set this up in my home lab. Again, all of this is not supported. The NVIDIA GRID hardware that we'll actually be talking about is already out in the market. You can go out and buy any of the cards, but the software that you need, the GRID driver, isn't available until August 32nd, i.e. September 1st, at which point you'll actually be able to play with this in your home lab, provided you have a new Pascal card, or if you already have an M60, you'll be able to upgrade your NVIDIA VIB. So my assumptions on this is basically you know how to run your environment, you know how to manage Linux desktops, you know how to manage your VDI environment. I'm putting in the extra pieces that you need to answer how to specifically do the vGPU. So again, not supported. Like I said, very clear thing that I was asked to make extremely clear on. So with that, let's get into a quick overview of the environment that I was working with. I was working with a C240 M3 Cisco host, and that's what was running most of my virtual desktop material on. So again, that's not supported with the P4 card. I was running an NVIDIA GRID P4 GPU. So that's the smaller half-height, half-width GPU card. So it only takes up a single slot and can run in smaller servers. Very fun stuff. And then on my management environment side, most of my management ran on a Dell R610. My virtual machine specs that I was running in this environment, and you can scale these up. I've done testing around other specs as well. But I was running 4 vCPUs with 8 gigs of RAM, and this uses the VMware Blast Extreme protocol. So Linux desktops with vGPU only support the VMware Blast Extreme protocol. In this session, we're going to be talking about the P4 4Q profiles and the P4 8Q profiles. And those have to do with how you slice the video card up. And we'll get into that here in a little bit. I've done previous testing, and if you'd like to go see what that looks like, there's actually a GTC session that you can go catch where I went through configuring Linux desktops with vGPUs using the M series or the Maxwell series cards. With that, we'll hop into the host configuration. I'm assuming everybody's gotten the card into the box. If you haven't been able to get whatever Pascal GPU card you are using into the box, please consult technical documentation from your hardware vendor. After that, and after you have ESXi installed on your host, it's time to install the NVIDIA VIB. So it's the Virtual GPU Manager. This is actually a really straightforward process. Quick ESX CLI, drop it in. You do want to stop Xorg before you actually install this, because it will update the Xorg config. So got the command in there for that. And then one more ESX CLI to actually do the verbose install. You do typically want to add a flag to allow the unsigned driver install on your VIB. In the past, there have been unsigned drivers with the NVIDIA VIB. This go around, not so much, but something to be aware of in case you get cannot install VIB is to check and see if you need to set the flag to install it. So, next thing we need to do is change the ECC memory mode on the NVIDIA GRID card. So the new Pascal line of GPUs come set with ECC mode enabled, and that's because a lot of people use those for deep learning, machine learning, and other wonderful things that aren't VDI based. So we want to flip that off, and that's just a quick command in the NVIDIA SMI panel. So basically hop on a command line, NVIDIA SMI -ECC config 0. And that shuts it off. Now, if you're using Maxwell cards, so the M60 cards, you want to go in and you're going to have to do what's called disabling GPU mode switch. That adds about 3 extra reboots into the cycle. So having this ECC change is actually a huge advantage. You don't have to go through and bounce the server a bunch of times. You just have to reboot it once after you set this ECC in place. Then we can start Xorg. We can verify that the VIB's been loaded up, and away you go. You can exit maintenance mode, and your GPU's there. It's ready for you to start using. So that gets us to stuff we actually need to configure inside the hypervisor. Best way to do this is typically on the GUI, and that's setting the default graphics to shared direct. That makes everything work. You don't do that, you get funny errors when you try and go turn this up. So getting that shared direct set on there is important, and you can see the 1, 2, 3 steps right there. That means we're ready for licensing. So at this point, you've got your host configured. It can handle vGPUs. We want to make sure we have licensing ready to roll, and then we'll build our virtual machines. So NVIDIA GRID Licensing comes in 3 different flavors. We've got the virtual application, which is really where you're sharing just a single application, typically RDSH. Then you have GRID VPC, or virtual PC, which is for your standard desktop users. And then if you want to get into the insanely fast, insanely high pace end, you have the NVIDIA Quadro Virtual Data Center Workstations, or Quadro VDWS. And those are awesome for the mid-range and high-range applications where you have people running CAD CAM and stuff, and they want to manipulate the environment. So those are the 3 types, and we're going to get into the licensing types. But first I want to call your attention to the big green box at the bottom. Some people who have experience in the past with NVIDIA GRID GPUs know that you don't really have to license it, especially on Linux VMs. Yeah, you could get by in GRID 4.2 days without actually going through and licensing your virtual machines. With GRID 5.0, licensing is enforced. Licensing is enforced on Windows virtual machines. It is enforced on Linux virtual machines. So if you don't have your licensing in place, your virtual machines will be crippled. So you do have to buy the license and keep a current license with it. So this wonderful eye chart is actually the P40 listing of all the different virtual GPU types that you can have. So P40 1Q all the way down to 12 or 24Q, which basically means you can split the card up from 24 host all the way down to just a single host to a single GPU. So lots of options there depending on what your performance profiles are. And all of the different Pascal cards, so the P4, the P40, all of them have a set of these profiles. You can find this on NVIDIA's website. That means we're ready to install our GRID licensing server. GRID licensing server, you can do it in two different ways. You can install it on a Windows-based host, or you can install it on a Linux-based host. I've done both of them. They rock. There's also a high availability option where you can have two different hosts there, so that even if your licensing server goes down, you have a backup one that'll take its place and still keep serving out the licenses for you. All of this is detailed in the GRID license server release notes, which you can get if you go and do the try GRID option at NVIDIA. So that gets us into installation. Obviously, since I'm talking about a Linux deployment, we're going to use a Linux licensing server. It's fairly straightforward. You need to install Java, you need to have Apache Tomcat in there, and then you install the licensing server. And you can see the commands for this on the screen. All of those go in. It's literally following the next, next, next button. The important point to note about step number 2 in here, which is the firewall options during the license server install, is that port 7070 is checked and port 8080 is unchecked. Because if you have port 8080 unchecked, that makes your license server wide open for people to connect to it from the outside and look and manipulate your licensing. So you want to keep that checked, so you actually have to connect to the box and have that security at that level. With that, you can verify the installation by going to the local host on 8080, and you can actually see that your license server is up and running. Okay, and give me just a second, because my clicker seems to be delayed. Seriously delayed. Okay, so gonna put this at a checkpoint real quick. We've got the physical cards installed, we've got the VIB installed, we have the GRID license server installed, and hopefully you have a template Linux VM that you're ready to use for this. You've gone through, you've optimized it, you've loaded the packages and everything that you want to run on that. That gets us to where we can start configuring the virtual machine. So we'll start with a powered off virtual machine, and we're going to go in and add a vGPU to our template virtual machine, which is real straightforward. Edit settings, go down, shared PCI device, and then go ahead and click add. Once you've done that, you want to go through and make sure you do a reserve all memory option on there. If you don't reserve all memory, it's not going to go out and actually reserve the memory on the card correctly. And again, you're going to have some issues when you try and power it up. You're going to get an error message saying can't power on VM, not enough available memory. So it's important to go and reserve all memory when you do that. Once you've done that, just power it up, and up comes a virtual machine with a vGPU in it. Now, you can't quite use it yet. There's still a few more things that you want to do. So we're going to continue configuring the Linux template. And if you notice up at the top right-hand corner of the screen, there's actually a configuration guide that VMware has put out for configuring that'll walk you through this for all of your different OSs. For CentOS, which is what I used in my environment, it's very important to do or to get rid of the VIRBR0. You want to disable that and go through and actually destroy that, because otherwise the VMware Horizon client or host client will sit there and try and do all of its communication over that virtual network adapter. And it's going to confuse the heck out of it. You've got to then go in and look at the logs to see which path it's sending it down, and go in, take that out, and reinstall the client. So it's very important to actually do that. That gets us to the rest of the little bits that need to be installed. We want to install GCC. Makes things so much easier. I happen to be a fan of just doing the development tools, but it varies depending on what you're doing with your virtual desktops. We want to go through, set the NSS switch config. Want to go ahead, and then we're going to drop this into run level 5, disable Nouveau, and a lot of times at this point I'm SSH'd into my virtual machine just because I can run all of this stuff really quick. And then we can install the drivers. So installing the drivers is real easy. You just want to make sure you do it in a specific order. First, you want to install the NVIDIA GRID driver. So drop into run level 3, stop the GDM service, and you're going to install the Linux driver. When you install the NVIDIA Linux driver, it is going to sit there and cause a black screen. So if you're going through the console, all of a sudden, once the install is complete, you're going to get a black screen, which is one of the big reasons I recommend SSHing into the host before you do the install, so that your drivers and everything work well. Once you've done the NVIDIA driver install, then you can go ahead and run the the VMware Horizon install on there for your host. And the important thing about that sequence is your Horizon driver has to match the NVIDIA driver and the VIB that you're using. If they don't match up, it's not going to work right. Sometimes it works, a lot of times it doesn't, because the instruction sets don't match from driver into the virtualization layer. Alrighty, so we're going to finish the driver configuration. It's going to ask you, do you want to configure X? Go ahead and say yes, reboot the machine, black screen like I said, and then the Linux Horizon agent, which we already ran through. Again, this is not supported, so VMware will tell you if you call in and say, I'm running a Pascal on a Linux virtual machine. That's wonderful, this isn't supported. I've run it in my lab, it works, but it's not necessarily a supported thing. So at this point, we can actually run NVIDIA SMI on the virtual machine. And NVIDIA SMI is actually a great tool that NVIDIA provides for their entire line of graphics cards. So just about any of them support NVIDIA SMI. And you can go in and you'll see that the red box here shows that I'm running a P4 grid profile. And you can see a lot of other information on here. And this is running on the virtual machine. I can get even more information if I drop down to the ESXi host level. That gets us back to linking that licensing server that we set up earlier into our virtual machine. To do this, we hop in and we edit a grid conf file. And with the new release, you'll actually need to copy the template file that they have and make modifications to that to point at your license server. You can also do these through policies or auto loads to adjust it to the license server that you want to use. In this scenario, we want to make sure we set the feature type equal to 1, and that's going to do the vGPU. If we set it to 2, that's actually for a pass-through device or non-shared vGPU. We're basically taking the whole thing, passing it straight through. We do a sudo restart on the service for NVIDIA GRID, and up we go and away we are. We can hop in our licensing server, and you'll see now that the virtual machine's licensed, which is a wonderful thing to verify before you go pushing these out to production, and is make sure and test that they are pulling license files. So, bunch of limitations that go along with this. Pascal GPUs are not officially supported. Been talking about this through the whole session. VMware vMotion is not officially supported or even available. But you can go to the NVIDIA booth if you're here today and check out a technical demo of vMotion if you're interested in seeing something about that. You cannot do VMware DRS. You cannot do instant clone support, so no instant cloning of Linux virtual desktops. You can't do snapshotting of running virtual machines because it can't capture the GPU state right now. And you have to use the VMware Blast Extreme protocol. Now to automate this, this is real easy. Assuming you are anywhere familiar with Horizon, it's going in, adding a new pool, and setting your 3D rendering type to VMware Blast Extreme. That's pretty much all you have to do. And away you go. So let's get into my testing and show you some of the numbers that we actually hit when I was running this in my lab on a completely unsupported configuration. The testing I did was with OpenGFX. So OpenGFX won't even load unless you have an OpenGL capable GPU. So it loaded. If it doesn't load, you can start troubleshooting there, making sure the driver and everything's in place. Then you can actually use OpenGFX to troubleshoot other things, other performance-related issues as well. So here are some of the screenshots and some of the high and low points on my GFX benchmarking that I did. And really, it's not even a benchmark. It was just a single pass test. And you can see I was pulling 63 frames per second on the low end on-screen rendering with the 8Q profile, which is the large profile. And then with the 4Q profile, I was pulling 64 frames per second. If I have problems in this where things seem really low, but I'm running a really high profile, I can start looking at memory constraints. I can start looking at CPU constraints and see if I'm constraining myself in some way. Oh, it bounced me out just a little too quick. I am so sorry about that. So, and yeah, so I do have a couple more testing numbers that I'd love to show, but it doesn't seem to want to let me into it. Down at the very bottom, right, keep going. There we go. Close enough. Okay, almost. One more. Okay, no there aren't. So, I had a slide in here and evidently I deleted that slide right before I came up on stage and didn't realize it. I actually have comparison numbers, and you can go look at my blog, wondernerd.net, and you can see the comparison numbers between a P4 and an M60 GPU, and actually see what the testing results are on those numbers. So you can see that there's not a whole lot of difference. When I was actually running the test, the frame rate difference between the M60 8Q profile and the P4 8Q profile was about 10 frames per second plus or minus. So lots of information there, and NVIDIA's done an awesome job shrinking that down and extending it into the next wave. With that said, big thank you to everybody who decided to come and attend the vBrownBag Tech Talks today. It's greatly appreciated. And if you're interested in catching slides from this session or any of my previous work, you can catch it on wondernerd.net.